So first we need to use the welding shield to cover our face. Next we need to use a pair of gloves, and after that we need to use the hammer, welding hammer, to remove all the residue from the welding, and the brush to brush off, and chalk to marking the welding part. Also the pair of safety shoes to protect our foot, and we need also to wear a pair of safety goggles and the mask. Last but not least, we need to wear the jacket and the apron to cover our body. We need to only to switch on the main switch to on the AMP machine, and next we need to switch on the AMP machine. So this part we need to clamp negative and positive terminal. Negative terminal we clamp the cable, and positive terminal we clamp the rod for the welding, and that's for this part. So this is the process before the during the welding. First we need to wear the pair of gloves and put the plate on the right position. Next we mark the welding area that we need to weld, and for the welding stick we need to stretch first before we start welding, and tap to the initial point at the welding marking that we mark with the chalk, and next we start the welding like usually we do. And when the rod become shortened, we need to replace it. But before we replace the rod and start the welding, we need to remove the welding residue by tapping the hammer and brush off the residue. And next we will continue the welding by scratching it off and welding until the end. So after ending the welding session, we need to cool it off, and we tap up the residue with the hammer, and we brush off the residue or the dirt from the welding plate, and we can see the result of our welding. After the welding session, we need to clear all of our area by sweeping all the residue, including the welding stick that has been shortened, and throw it into the dustbin near the welding area. Ding, ding.
Okay, before you start welding, you must wear PPE to protect yourself. So let's do the PPE from the bottom to the top. So the first is safety shoe. And then after that you must wear a safety jacket to protect yourself. And this is the welding mask to cover you when it's working, to cover you from the light. Then you also need to wear a mask to protect you from the gas producer when the welding are, and finally you must wear the thermal glove. So because the plate is very hot and the stick also very hot, so you must wear the thermal glove to protect you from damage. So at first I want to introduce this machine. This welding machine have two plates, and this is negative plate, and which have blue cover one is positive plate. And first you plate your negative plate to the working table, and second you take the positive plate and take the electrode, which is stick just after the positive plate. Wait, I think better I do an example for better understanding. Firstly is in the top. Just click after the click, not a seat, below the click, not like this. You just click after the, you just click before exit the click. And then you also want to put your leg. You also want to put your leg beside the apron. Also want to put your leg. Your leg also want to cover by this apron. Because when you're welding, the spark will come out and it may hit your leg. It may damage your leg. As I mentioned just now, we place our leg to a position that can be covered by the apron to prevent the spark generate from while welding hit our leg. So here we take a stick and we grip it using positive grip. So we grip it just at the end of the positive grip. It should look like this. So I also want to add something that I forgot to mention at earlier. So in which before we start the welding, we need first preheat the stick by drag the stick to the abundant metal. And there are also another method used to preheat the stick, which is dipping. But this require high welding skill because when you're dipping, it may be stick on your abundant metal. So, but the advantage of the dipping is you can reduce the weightage for the preheat. So why we need to preheat? So if you are not doing the preheat, the stick will stick on the metal. And what happen or what to do when our welding stick is stick on the metal? The solution also simple. You just shake the clip and to break the connection between the stick and the metal. So here's the example what I do when the welding stick is stick on the metal. So for a good welding, you just start to hold the grip and make a 75 degree to the table and just slowly drag the grip to the metal. So if you're too fast, the weld will become too small, and if you're too slow, the weld will become too big. So, and you slowly move your grip from 75 degree and to 90 degree as the stick is less and less, shorter and shorter, so that you can make sure the stick is always contact with the metal to prevent the stick is too far well from the metal. Okay, after you finish your hot work, you want to remove your strut. So how you gonna do this is you take this hammer and you create it in 45 degree. And you knock it in 45 degree. After that, you take the brush out all the sludge.
In this video, I'll be demonstrating my welding process and evaluating the quality of the weld beads produced. For your information, welding is a critical skill in fabrication and engineering, where proper technique directly affects the strength and reliability of a joint. Throughout this video, I will show the results of my weld, identify key characteristics such as bead appearance, uniformity and spatter, and discuss areas that can be improved. These include factors like travel speed, arc control, and electrode angle, which all play an important role in achieving a strong and consistent weld. By the end of this video, you'll get a clearer understanding of common welding mistakes and practical ways to improve overall welding quality. Putting my video as an example, my weld run from start to end without major breaks, which means my arc stability was okay. And as for basic bead formation, I have visible ripples, which means I was moving at a consistent pace. However, there are some issues regarding my weld results as well, which is the excess spatter, which is caused by incorrect current, arc length or poor electrode angle, and slack or contamination, which caused the surrounding area to look dirty. So how can we improve it? Firstly is to control our travel speed, then to maintain a consistent arc length, and then to improve electrode angle and adjust current amperage.
So my name is Haikal Amirul, and from this video I will do some discussion that we got from this lab. So we got to study the shielded metal arc welding SMAW method, or we call as stick welding, and was supervised by the instructor, and also student got to carry out the stick welding method on the milled steel plate using the certain striking shape or technique. First, we must wear the PPE, personal protective equipment, such as safety boots, jacket, apron, glove, and face shield. And also, the welding will produce the fumes, which is a mixture between the metallic oxide, silicates, and the fluorides, and might be uncomfortable for the student. Thus, the welding area must be well ventilated to prevent from feeling suffocate. Welding also would create sparks and hot slag, which could cause the ignition near the flammable items. Thus, the welding spot also need to be clear from any flammable material. The stick welding method could happen when the electric circuit is complete. The electric circuit will comprise of the electric power source, a welding cable, electrode holder, and the ground clamp, which is linked to the electrode to the surface that wanted to be welded. Welding will occur when the arc is formed between the surface and the tip of the electrode. When this happens, the circuit is complete. Thus, the surface of the plate and the electrode will melt, forming a pool. The melting of the electrode will also release the vapor, which is shielding gas. A layer of slag was then formed to protect the weld side. The tip of the electrode becomes the metal as it transmits energy from the electric arc to form the weld pool, which is later cools and form a connection between the materials. Welding happens at very high temperature, which can access up to 9,000 degrees Fahrenheit. Some of the stick welding method benefits is that its equipment is cost lower than other welding method. Compared to other welding method, stick welding method is requiring less equipment and simple. It also easy to use and have good mobility for the equipment. The equipment is a lightweight, portable compared to the other welding method. Thus, this welding method can be used widely and for many types of maintenance work, including where the welding place is limited with space. Next, the stick welding. SMAW welding has its own protective gas generated from the covered electrode, and there's no additional exterior shielding gas needed. This makes the welding process easier than other welding methods. Finally, the stick welding method can be used for many varieties of metal and alloy, and the welding can be done in many different positions also. Some of the disadvantage of this stick welding method is the welding process will be done manually. This means that the welding quality depends on the skill of the welder itself. Thus, high competency welder is needed for a more challenging welding job and position. Next, the stick welding method also could produce lower productivity because of the welding process is manual, and it depends on the welder skills to accomplish the job within the duration. Last but not least, because the electrode will get shorter during the welding process, the electrode need to be replaced many times during the welding process, making the welding job complicated. That's all from me.
Assalamualaikum and hi everyone. So for the conclusion part, this experiment is successfully for introducing shaded metal arc welding. So as a student, we gain a better understanding by welding techniques like sticking and plate welding. So at the lab, it shows how this welding skill are applied in real industry, especially at the machining. So this experiment is success connecting with theory and with application, making it more success and understanding.